Hi there, my name is Douglas Penna. I'm the lead data scientist in the rankings team in Farfetch. And today I'm going to talk about how can we go from legacy to vision? Or in other words, how can we adapt continuously our current systems to the state of art? So legacy is something that exists everywhere, right? You can be a new startup starting from ground zero, nothing there, or you can be a traditional company that's been in the market for 30 years. It doesn't matter. It just changes what type of legacy you're going to have. When we talk about legacy, we think more about the corporation type of legacy, that you have that black box system where nobody knows who built that, nobody has access to the code. They just know that this solves the problem, right? And nobody wants to touch that. This is one type of legacy, and nobody wants to have that too. The second one is the one that exists in startups. And it's whenever you're building something, you want to build as fast as possible. But to build as fast as possible, you have to reduce a little bit of the quality. So you don't pay proper attention to design or to tests. You just concern that that particular module, that particular functionality works, right? And what happens over time is that you're gonna have a system that is completely patched. You have a lot of different ideas that they don't glue well together, right? And then it's difficult to maintain, it's difficult to create updates. So this is a sort of kind of legacy too. So how do you deal with that? So one of the ways that people choose to work with this is try to let the organic part of the system that was built to be there. And you keep refactoring one bit at a time. So now I'm gonna spend my time here just to refactor this code. But a few people, they are not comfortable with this. So I'm gonna spend like a lot of time just to refactor the code, to refactor something that already works without driving any new functionality. That's difficult to sell, right? And the other thing that people believe is like whenever the code is so complex, it's so entangled that you know what, let's build something new. Let's build this new platform, and whenever we have this new platform, things are going to be great. All our problems will be solved. We're going to have access to data, to computer resources, and I'm pretty sure everyone has heard of something like this at some point in their careers, right? But this new platform, it's going to take 9 months, 1 year to be complete. So what are you going to do until then? You're going to have like a team isolated, building something like this, disconnected from the rest of the company. So it's a big bet. It's a hard choice. So what can you do? We suggest we go something in between. So this is a chart that's not based in any data. It's just experience, gut feeling about how things go over time and the cumulative functionality that you create. So when you don't have design, you can perceive that on the short term, you deliver a lot of stuff, right? It's the same feeling you have in a hackathon. You just go there, you build something, it has a particular functionality, you test an idea, and that's great, right? But over time, on the long run, it's not good because the system starts to be too complex and it's difficult to maintain and to update. But if you have good design from the very beginning, if you invest in tests, if you try to at least test the functional things, what that part of the system should do, and then you can create more tests based on that, but at least the minimum, right, on how you create your stuff. And on architecture design, how this new product interconnects with the rest of the system. So if you invest this, on the very short term, you feel that you're not producing, double quotes there, a lot of things, you're not delivering value. But after a while, it's easier to maintain, it's easy to fix, it's easy to try new things, right? But this would be what I would say the brand new building. And this other one is like the hackathon style. But something that you can do is in between is when you embrace refactoring every day. So whenever you receive a new piece of technology, a new functionality, or a new story, or a new something that needs to work with whatever exists in the system that was developed in this blue phase here. You know what? I think I can do this in 1 month, but try to add a little bit of extra time so you can refactor the components that that piece belongs to. So you deliver the new functionality, but you also refactor. So, and you keep refactoring over and over. It's business as usual. It's part of your daily activities. So you are delivering value, but you're also paying the debts that you created over time. But to have a direction, to know where you want to go, this needs to have an architectural vision, right? And this vision here is extremely inspired by what we have in TensorFlow. TensorFlow X, TFX is an architecture developed by Google. And I do believe the way that they have designed this is very similar to the way I think about data science. So first, you have to, your data science problem use pairing components, right? One is data ingestion, so that reads from those places and put the data that needs to be processed in this location. And each one of them continues that process. So after you have ingested the data, you do some statistics generation. You try to understand average, categories. You try to, depending on the types of data, you're going to run different tests, right? And then you validate this data against what you have in the past. So is this format similar to what we have seen before? Yes, no, or is it too different? Because if it is too different, then I need to warn my scientists, hey, listen, there's a possible problem here. And then you create a schema, or you enforce a schema that okay, my data will be in this format. And if it's not, please tell me. And after you have this initial ingestion and preparation done, then you enter in a transform part where you're gonna engineer new features, you're gonna create embeddings, whatever you like, right? And making the data ready for the trainer. And the trainer does only that. Given a set of hyperparameters, you train your model. And this is controlled by a tuner, because the tuner can say, you know what, I'm gonna check this range of hyperparameters. I'm gonna try to identify which one of them is the best for my current case. All of this is evaluated by the evaluator that can measure not only accuracy metrics, but can also measure things like coverage, recency, popularity, and things that goes beyond those accuracy metrics, right? That tries to give you a full picture of the whole system and how the model is performing. After you have this done, you have, okay, I pick the model. I know which model I'd like to go for an experiment, an A/B experiment live. I create an artifact that can be used to deploy an API, or can be used in a batch process. And this needs to be validated. So, okay, do I have the infrastructure for this? Do I have to create new pods or a new cluster or whatever new part of the system to actually deploy that? If so, this is where you do it. And then after everything is done, there's a component that's I call the human in the loop that helps on the very beginning to make your stakeholders comfortable with whatever you build, so they can see what's happening there, and then they can provide feedback. So we can change how we are building this to be a better match of what they consider is correct, right? At least on the beginning. And then we can iterate this over and over to have the best scenario. And all of these parts, they're going to store data into a metadata store. So the data ingestion, what is the lineage? What's the type of transformation? And so on. So every run that we have, we're gonna record everything, so we can compare this over time. This is connected to data science life cycle. And the way that data science works, it's a bit different than software engineering. So in a way that this part works almost at the same time. So you have a question, you have a hypothesis you want to test, and then you start acquiring data, you start exploring the data if you're not familiar with that domain. Try to understand what's there, try to check for missing values, how you handle them, how you pre-process this data. And then based on this knowledge, okay, based on this question, I know I can create some features like this, and I can try using model A or B, and then you evaluate that model offline. And then after you have a good candidate, you go for an A/B testing. And once that is over, you can finally deploy this live and replace whatever models you have there in production, or have more than one running. And this is connected with the previous step in the following way. So this initial part is more about data acquisition and understanding, right? And as long as you keep going into the final part, it will be changing naturally between these steps. So the next, after you have the data and you understand the data, you go for a little bit of the modeling process from the previous slide, and you try to do some offline evaluation of what you have there, and then you go for the deployment, right? That mainly, those parts are mainly deployment parts, but for example, the pusher will create an artifact that will be tested in an A/B experiment, or it will be used for the evaluation of the human in the loop. So it's not like binary things, it's not a classification, but they have this interaction. And the way your team can work on this is that this is mainly data scientists. This is data scientists with the support of engineers that they can pair program, so the scientists can learn more about best practice in software design, in software engineering, testing, and so on. This part is mainly driven by engineers, and then but they have to consult with the scientists so they can understand if what they are delivering is actually what the scientists created there. And the human in the loop, which where the product person or the stakeholder can come in. They don't have to understand this whole part here, but they want to just take a look on the final result and see if that's acceptable for them to go to an A/B testing with real customers. So this is what we suggest you do. Whenever you have a problem with legacy, try to use more refactoring on the go. Try to estimate things and add a little extra there to actually build this and to fix the things that you've done in the past that you are not happy about. Try to align the architecture vision that you had here and the process of your life cycle, like we have shown here, right? And because when you do this, it's more natural, it feels more consistent and feels more organic, and people know what to expect for each one of these things. And if you are a data scientist, for example, oh, I'm a data scientist, but I want to go for the end-to-end. I want to acquire the knowledge of a data engineer and a machine learning engineer. No problem. So they can be more engage with those two parts here if they want to, but it's more like a separation of concerns, right? And people can focus on what they are really good at. And most important, you have to make your team happy. You have this, all of this that I've explained, it shouldn't be imposed in the team. Oh, now from now on, you're gonna do it like this. This doesn't work. It's aggressive, and sometimes the teams they don't view it in a good way. So what's the best way, in my perception, is that you try to introduce this step by step. You try to, oh, there is a problem, and then we can use this way of thinking. Oh, I don't have an understanding of the end-to-end system. Okay, let's build an architecture. Oh, whenever I'm building something and I'm committing, I'm not sure if I'm going to break something. So I have to keep looking at the stage or even the live environments. If something is broken there, okay, why don't we add a few tests there? So try to connect the problem they perceive with the solutions. And this gets introduced little by little with the team, so they are comfortable of using this in their daily activities. And finally, a massive thank you for each one of you. This is how we are doing things in Farfetch. And if you want more details, don't hesitate to contact me at douglas.penna with double N at farfetch.com. And we are hiring. So if you liked what you see and you want to work with us, please reach us. Thank you and goodbye.